So we're gonna add as many columns as factors we have. In this case, we have 4 factors, so we add 4 columns. So the first process is to add by pairs. So we have added the pairs. Now we subtract by pairs. But in this case, it's the lowest, the one in the bottom, minus the one in the top by pairs. Now we select the whole column and we drag to the right. Estimate the effects equals the contrast over the number of replicates, which is 1, times 0.5 times 2 to the 4, because 4 is the number of replicates. The number of factors, not replicates, the number of factors. So 1 time, okay. So to perform Daniel test, we have to make a chart. So we're gonna graph this one, scatter graph. We can see that these 4 points, do not go follow a straight line. So those points are the variables that have an important effect. So that A is significant and CDAC are also significant. We have to make an ANOVA, and so we have to make the sum of squares. The sum of squares, we can calculate it from here. Sum of squares, it's equal the contrast squared divided by n, which was 1, times 2 to the 4, because we have 4 factors, which is its individual variance over the individual variance of the error. We have to calculate the f of degrees of freedom, of 0.05 with 1 degrees of freedom in the numerator and 11 on the denominator. Yes, 0.004, which indeed every number is higher than 0.004. Y expected, it's going to be equal to the average of the data plus 1/2 of every significant effect. So we write the variable XA, and in here what's going to be, it's going to be the signs of the A factors. So this is our regression model. So in here, this is going to be equals of this plus this times this plus this times this. Okay, and this is our expected values. Now to get the residuals, we have to do the observed minus the expected. The residuals are observed minus expected, and we obtain our residuals. We make the graph. Now we can see that most follow the straight line. We plot this on a scatter graph, and we observe the dispersion. In here, we can observe that A on its low level has a significantly lower dispersion than A at its highest level. Now remember, we have to check the distances between the highest and lowest points. And what we're going to do is we're going to write the signs of A under A. And what we're going to do is we're going to calculate the variance when the variable is high. We're gonna calculate the variance when the variable is low, and then we're gonna calculate the f. Indeed, the f are going to be the dispersion effects. So we're gonna equals the variance when A is high, so it's going to be on the residuals. So it's going to be 1, skip 1, skip 1, select, skip 1, select. Then we're gonna do it when the variable or the factor is low. So select 1, skip 1, select 1, skip 1. The f is going to be natural logarithm of this divided by this. Once we have all the dispersion effects, we have to perform a Daniel's test on the dispersion effects. And then we actually graph it. We can see that indeed, as we said in the beginning, this point, which is A, it does not follow a normal distribution, so A has a significant effect on dispersion. Then we can say maybe this factor affects dispersion, which is factor B. Then we can say yes, well, factor B can also affect dispersion. So A and B affect dispersion. We have to obtain the averages. For example, we have to obtain the average for every significant effect and interaction. With this, we obtain averages of A when it's high, which means skip 1, select 1, skip 1, select 1. We assume we want to minimize the UEC, the response value variable. Since we want to minimize, we have to then select A minus, because A, when it's in the low level, has a lower average. Then we go in here, we have to do the average when both A and C are high. To do that, we can do a little trick, and then we can go and see the standard order, and both A and C have to appear. And now on dispersion, we have to consider also dispersion. In here we obtain that A and B has an effect on dispersion. Let's go to the graphs of dispersion, and we'd say, well, B plus has a lowest dispersion, so we select B at its high level. And then we would have to check the dispersion for A, and in here we clearly have that A at its low level has the lowest dispersion, which is what we have obtained in here. Now for the contour plot, we're gonna need the model regression. Let's make in here a 20 by 20 table. So it's going to be, we're going to select the first one, and we're going to select the average. And then we're going to add the effect of A and multiply it times the number on the top of the column, of that column. So it's going to be that effect of A times, and then we're gonna do the same for the C times, but it's going to be the number on the left of that row. And we're gonna select, and then in here it's going to be on the left side, and then we scroll it into 141, and we have our contour plot, but now we have to actually paint it. Conditional formatting between 0.59 and 0.61, oh, hold on, and 0.61. So yes, indeed, we have a contour plot with straight lines.